Okay, welcome to another video on functions. We've done a first map on functions. This is the second one. This has some interesting questions. Let's start looking at them. It says the diagram shows a graph f inverse of x, where f of inverse of x is defined by this. Okay, and find an expression for f of x. So you find f of x in the same way that you find the inverse. You take the inverse function, replace f inverse x with y, and then try to make x the subject this time. So I get 2xy plus 5x equals to 1, x 2y plus 5 equals to 1, so x equals to 1 over 2y plus 5. So f of x should be 1 over 2x plus 5. Okay, then it says state the domain of f. So the domain of f is equals to range of inverse. Okay, so I can see in this question that the inverse itself had a domain which was between 0 and 2. So this function was at 0, it seems to be going to infinity, so I can say that the range of the inverse is y is less than infinity. But what is it greater than? It's stopping at 2, so I can find out the value at 2. Let's say, how would I find that out? I'd say y1 minus 5 times 2 divided by 2 times 2, and that's going to give me minus 9 over 4. So that was greater than or equals to minus 9 over 4. So the domain of f will also be x is greater than or equals to minus 9 over 4. Okay, then in the next part it says the function g is defined by g of x equals to this. For x is greater than or equals to 1, find an expression for f inverse gx. So in the function f inverse, I have to replace x with gx, so I'm going to write 1 minus 5gx over 2gx, giving your answer in the form ax plus b, where a and b are constants. I think that's simple. 5 into 1 over x and 2 into 1 over x. Whenever I have a fraction upon a fraction, I have a habit of writing this as a divide sign so that it's easier for me to manipulate. Okay, I can take an LCM here and reverse this and say that this gives me x minus 5 over 2. I want it in the form ax plus b, so I'm going to separate the two and tell you that that is the final answer. Okay, that matches with the answer here as well. Going on to question 2, it says find the value of x for which fg of x equals to 7. I see that f of x is a linear function and this is a rational function. So fg of x equals to 7. So fg of x is basically 2 times 4 over 2 minus x minus 5, and I want that equals to 7. So 8 over 2 minus x minus 5. So that's 12, 8 over 2 minus x. 24 minus 12x equals to 8. 16 equals to 12x. X equals to 16 over 12. That's 4 over 3. Okay, that's my final answer for this. Then it says express f inverse and g inverse both in terms of x. That's simple, I think. So y plus 5 and divided by 2 should give you x, and that's f inverse of x. X plus 5 over 2. Then g inverse is also simple. Y equals to 4 over 2 minus x. 2 minus x equals to 4 over y. 2 minus 4 over y equals to x. So g inverse x. 4 over x. Part 3. Show that the equation f inverse equals to g inverse has no real roots. So x plus 5 over 2 Okay, so then x squared plus 5x equals to 4x minus 8. X squared plus x plus 8 equals to 0. So I can just do minus b. Okay, I'll just do b square minus 4ac and show you that since this is less than 0, although there are other ways of showing it as well. Since this is minus 31 when b square minus 4ac is less than 0, the equation has no real roots. Sketch on a single diagram the graph of f and f inverse, making clear the relationship. So I'm going to draw the graph. I can see that there's a y coordinate minus 5, 2x minus 5, and the x-intercept will be 5 over 2. Okay, so that's the graph of fx. I can also find out the graph of the inverse function, but let's just first draw this line for y equals to x. So the point 0 comma minus 5 comes here, and the other point is going to be here somewhere. This is going to pass from here. Okay, so that's the graph of f inverse of x. All the points get changed. This is 2, this is 3, this is minus 5. So the coordinates have been switched, as was explained in the lectures before. Okay, question 3 says x squared minus 2x plus minus 15. So I always do the comparison. I have x squared plus 2ax plus a squared plus b, x squared minus 2x minus 15. So 1 equals to 1 when I'm comparing x squared to x squared. Then minus 2 should equal to a, and minus 15 should equal a squared plus b. So a is minus 1, so b is minus 16. So I get x minus 1 whole square minus 16 as my final answer. Then it says the function p is f is defined for a certain domain where p and q are positive constants. The range of f is given by this, where c and d are constants. State the smallest possible value of c. So the smallest possible value of y will certainly be the turning point. Okay, this graph is a happy face graph. So the turning point I can see from my completed square form is 1 comma minus 16. So the minimum possible value of c can be minus 16. There can be no other possible minimum value of c given that the domain is unknown. So I'm assuming the domain is all real values of x. For the case where c is 9 and d is 65, so this curve is going from 9 to 65. So it's starting after the turning point or something like that. I will have to calculate. So the range is from 9 to 65. Find p and q. Now at 9, if I keep this as 9, f of x is 9, c and d are 9, right? Okay, so 9 is our positive constants. Okay, x squared minus 2x minus 15. I could use the completed square form as well, that's up to me. Right now I'm just using my calculator to solve a quadratic. That's part 3. So this gives me x minus 6 and x plus 4 so x equals to 6, x equals to minus 4. So this is true and this is discarded. Why? Because it said that p and q have to be positive constants. So that's p. 65 equals to x squared minus 2x minus 15. X squared minus 2x minus 80. 10 and 8. X equals to 10, x equals to minus 8. Again, that gets discarded. Sorry, that gets discarded. And that's the correct answer. Find an expression for f inverse of x. So the inverse of a quadratic function always starts with the completed square form. We get y plus 16 equals to x minus 1 whole square. You take a root on both sides and you get y plus 16 equals to x minus 1. Now there's a possibility of both a plus and a minus. Now I know for a fact that my curve has not started from 1, it started from 9 and going up to um, it started from 6 comma 9. What did I get? Yeah, 6 comma 9 and 65 10 comma 65. So I can say that it's to the right of the turning point, therefore I'm going to put a plus outside and say that this becomes 1 plus y plus 16 equals to x. F inverse, that is going to be my final answer. Okay. Um, Question number 4. Now this is what we call a piecewise function because it's in two pieces. And each piece has a separate domain and a separate range. Usually their domain overlaps in the sense that this is ending at 1 and this is beginning at 1, but their y coordinates are also matching, so you don't see a discontinuation. It's a continuous curve. The diagram shows a function this for minus 1 to 4. State the range of f. So for the range of f, I'll need this endpoint and I'll need this endpoint. In any case, I should also calculate this to see if both of these match. Of course they will, so 3 times minus 1 minus 2. That gives me a minus 5 at the bottom. And then I can just check for this. That's 1. So I think that's 1. And then for the endpoint on the line above, 4, 5 minus 4 gives me 4. So I have this as 4. Okay. And yeah. So the range of f is basically from less than 4 and greater than minus 5. Copy on the diagram and on your sketch show y in f inverse of x. Okay, so this point is 4 comma 4. Even if I were to switch the x and y coordinates, they would remain as it is. I'm not drawing this again, of course. This is 1 comma 1, so this point would also remain that. And I know for a fact that the line y equals to x has to be drawn here, so the line y equals to x will be something like this. This is the line y equals to x. As to how I am to draw the inverse function, let's look at that. I know that this point is minus 1 comma minus 5. So this would in turn be visible at 1, 2, 3, 4, 5. Okay, so this would in turn be visible at minus 5 comma minus 1, so somewhere here. Now when I'm drawing this, what I should do is I should draw something like this. Okay, and to show the reflection this, because it's a reflection in the line y equals to x, so the green line is basically the inverse function. Okay, obtain expressions and define the if inverse, giving also the set of values for which each expression is valid. This is a 6-mark question, so you change the first part first and you say that this inverse becomes 3x and x equals to y plus 2 over 3. So f inverse of x is made up of x plus 2 over 3. I'm going to make f inverse of x in the same way that I've the normal function. I'm going to say that x plus 2 over 3. Now what is the domain of this graph? The domain of this graph is the range of the previous one. So the range of this straight line was from 1 to minus 5. So I'm going to say that x is between minus 5 and 1. I've written that too close. Let's just move it a little farther away. Okay, so from minus 5 to 1, as you can see on the values of x, my inverse is visible as a straight line. What about the other one? The other one looks like a rational function, so I'm going to Do the same thing, y equals to 4 over 5 minus x. 5 minus x equals to 4 over y, and 5 minus 4 over y equals to x. So this becomes 5 minus 4 over x. That is also f inverse. For what values is this valid? You can see from here that it's going from 1 and ending at 4, but since 1 was included in the previous one, I'm going to write this as not included and this as 4. Okay, because it's taking on the values from 1 to 4 on the x-axis if you look at this inverse. Okay, so that's that question. I got 6 marks for this because it's important to write these correctly. And they have the same principle that the range of the inverse function is the domain of the original function, and the range of the original function is the domain of the inverse function. Okay, moving on to the next question. The function f is defined by f of x equals to 2x plus k, where k is a constant. The case where k equals to 3, solve the equation f of x. So 2 times 2x plus k equals to 25. Okay, sorry, I missed something. I'm doing f of x. So 2x plus k outside. So 2x plus k equals to 25. I want to take k as 3, so that becomes 4x plus 2 times k plus k equals to 25. 4x plus 3k, so 3 times 3 equals to 25. 4x equals to 25 minus 9, and x is therefore equals to 4. Then part 2 says the function g is defined by a quadratic. Find the set of values of k for which the equation f of x equals to g of x has no real solution. So this is a question from quadratics itself. So I'm going to say that x squared minus 6x plus 8 equals to 2x plus k. Okay, so b squared minus 4ac is less than 0. Okay, so 4k is less than minus 32 and k is less than minus 8. I think that's simple. The function h is defined for x is greater than 3. Find an expression for f inverse h inverse of x. Now I know for a fact that the inverse function cannot be obtained for a quadratic till I have the completed square form. Now since this question is not telling me any completed square form, what am I going to do? I'm going to use my own completed square. I'm going to complete the square on my own and then obtain an inverse. So first I'm going to use a completed square form that says ax minus h whole square plus k. Ax square minus 2ahx plus h square plus k. So ax square 2hx, sorry, 2hx. 2ahx plus ah square plus k. So a is 1, minus 2ah is minus 6. So h is 3, and 8 square plus k is equals to 8. So 1 times 3 squared plus k equals to 8. K is equals to minus 1. So my completed square form is basically x minus 3 whole square minus 1. I will use this form to obtain the inverse. I'm going to say that y plus 1. Then I put a root. When I put a root, I have to decide whether it's to the right of the turning point or to the left of the turning point. Here I see that x is greater than 3, which means that the turning point is 3 comma minus 1. And this is to the right of the turning point, which means I must have a plus outside. So that gives me 3 plus root of 5 plus 1 equals to x. And f inverse of x is therefore 3 plus root of x plus 1. Okay, the next question is also a piecewise function. I can say that this is in two pieces. Okay, let's see what the question says. The diagram shows parts of the curve y equals to 11 minus x squared and part of the straight line y equals to 5 minus x meeting at the point A, P comma Q, where P and Q are positive constants. Find the value of P and Q. Since it's saying they are meeting, so the simple idea is that I can solve them simultaneously and get to one final answer. So x squared minus x plus 5 minus 11. So x squared minus x minus 6 equals to 0. And I can say that the two values that I'm getting are 3 and minus 2. Of course, this should be 3. It can't be minus 2 because it's not on the negative side. And to find the y value, I can just put it in one of the equations and find out the y coordinate. So this is 3 comma 2. That's what I found out for the first part. So that's 3 marks. The function f is defined for this. Express f inverse of x in a similar way. So I am going to start making the inverse since it's divided into two parts. The first one is a quadratic. So what I'm going to say is that I can see that this is already the completed square form. I can write it at x minus 0 whole square. So I can start with this. I can just say that this is 11 minus x squared. It won't matter. 11 minus y. And then I take a root. When I take a root, I know that I have to decide between a plus and a minus. In this case, I'm going to decide it's a plus because I can see that my graph is to the right side of the turning point. Okay, so therefore it's a plus. So f inverse of x is basically root of 11 minus x. Okay, we found out the function, but um, you see this was valid for 0 to p. Now if I need to write it in the same way, what I'm going to tell you is that I have to write f of x. I have written the first piece, and that is root of 11 minus x. For what values is it valid? I'm going to say that the range of this function, that was from 2, and I can see that this point is 11. Since the range of the original function was from 2 to 11, the domain of the inverse function will also be from 2 to 11. Let's see if 2 is included. Yes, it's included in both, so that should work. For the next part of the inverse, I'm going to say that I take the other line and I try to make x the subject. So f inverse of x is basically 5 minus x. Okay, so I'm going to write 5 minus x. What values does it start from? I know that this value is 2. It's going to be not included because 2 is included in the other one. And there is a certain value of y here. So the range of the original function, that's what I'm talking about. So I'm going to say that the range of the original function is there's no bottom limit to actually the range because it says that the graph is continuing. I don't see an end to this. So it's just starting off here. So I'm just going to say that x is less than 2 for this function because the range of this line is y is less than 2. So the range of the original function is equals to the domain of the inverse. So yeah, that is the answer. We can write whichever one first, although I should write the one that's lesser first. Okay, so this should be up here, but it doesn't really matter. Question 7 says the function f and g are defined by f of x equals to this. Express f of x in the form ax plus b whole square. So 2x squared minus 8x plus 10 equals to ax plus b whole square plus c. So a x squared plus 2bx plus b squared plus c. So ax squared plus 2abx plus ab squared plus c. So a is equals to 2. B equals to minus 8. So 2ab equals to minus 8. Or minus 2. And ab squared plus c. So a b squared plus c. So c is also 2. So I get 2x minus 2 whole square plus 2. State the range of f. Okay, for the range of f, I will need the turning point, that's 2 comma 2. Okay, and I need a small sketch of my graph. So I'm going to say that this graph starts off at, it has a turning point at 2 comma 2. It's a smiling face graph, and since this 2 is also on the boundary, I just need to worry about 0. So I'm going to plug in 0 and say that f of 0 equals to 2 times 0 square minus 8 times 0. I can also see that it has to be 10 because it's the y-intercept. So 10. So let's make it a little lower and say that this is 2, 4, 6, 8, and 10. Okay, so that's the other point. So what values am I talking about? The values that I'm talking about are y is greater than or equals to 2 but less than or equals to 10. State the domain of the inverse. That has to be the same as the range of the original function. So again, 2 and 10. Sketch on the same diagrams the graph of this and that, making clear the relationship. So I think that is simple now. You can see that this I can draw this again, and this time let's draw a slightly larger graph because I am going to need these values. Okay, so 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So let's first draw the line y equals to x. Uh, so let's draw the line y equals to x. So I had 10 and 0 and 2 and 2. So my line looked, my curve looked like that. This time it's going to get reflected, and instead of 0 comma 10, I will have 10 comma 0, and the graph is going to look like that. Okay, so it was supposed to be turning from here, but unfortunately, and turning from here that way. But it has to stop at the turning point for it to be a valid function. Find an expression for inverse. I think that's simple. So you start off with the completed square form, and you say that y minus 2 divided by 2 equals to x minus 2 whole square. You take a root, you decide whether you want the left hand side or the right hand side. The original graph had the left hand side, so I will take a negative outside the root and say that this becomes x minus 2, 2 comes here, and that is my inverse function. Okay, a negative outside the root because I have the graph to the left of the turning point. Question 8 says the function f is defined by this, where c is a constant. Is given that f is a one-to-one function, so it must stop at its turning point. Okay, so it's defined for a range greater than c, so I can confidently now think about c as the turning point of the graph. State the range of f in terms of c and find the smallest possible value of c. I know that the smallest possible value of c is going to be the x-coordinate of the turning point. How do I find the turning point from this form? Either if I have this classless calculator that I have on my screen, I don't have it on my screen right now, but there's a separate video telling you how you can find the turning point from this. Right now, I can just tell you that we've learned that x coordinate of turning point is basically minus b over 2a. So you can say that it's going to be minus 4 over 2 times 1, that is minus 2. So this c should be minus 2. Why? Because it must stop at c, so that it goes like that. It starts from C and then goes up like that. Okay, it's a smiling face, that I know for sure, and that is what it's going to be. But I wanted the range in terms of c, so I'm going to say that I will calculate f of c and say that c square plus 4c, and I will imagine that the curve is starting from c, so the y value has to be greater than or equal to c square plus 4c, because my graph must look like that. It's a part of the quadratic graph, but it's one-to-one, so it has to start at its turning point. Okay, then it says function g is defined by ax plus b. For x is greater than 0, where a or b are positive constants. It is given that c equals to 0, gf equals to 1 g of 1 gf of 1 equals to 11 and fg of 1 equals to 21. Write down two equations in a and b. Okay, so I have to use composite functions to do this question. First, I'm going to write down my original function so that I don't make a silly mistake. I have x squared plus 4x, and where x is greater than or equals to 0. That's what the question is telling me. C is equals to 0. Then g of x is basically ax plus b for x is greater than or equals to 0 as well. Then it's telling me that gf of 1 equals to 11. So gf of 1 equals to 11 and fg of 1 equals to 21. So in order to avoid confusion, what I'm going to do is I'm going to create the functions gf of x first and say that gf of x is basically a x squared plus 4x plus b. I've replaced x with f of x in the function g, and for fg of x I'm going to say that this is ax plus b whole square plus 4ax plus b. So I get ax squared plus 4ax plus b equals to 11. 11 equals to a times 1 square plus 4a times 1 plus b. So a plus 4a plus b equals to 11, so that's 5a plus b. Then this is 21 and a into 1 plus b whole square plus 4a into 1 plus b. So I get a square plus 2ab plus b square plus 4a plus 4b. So I have 21 equals to a square plus 2ab plus b square plus 4a plus 4b. Nothing gets replaced. From here I can see that there's a substitution. 11 minus 5a, so I'm going to do that. It's a 6-mark question, which is why it's slightly longer than other questions. Okay, so 21a squared plus 22a minus 10a squared plus 121 minus 2 into 5, 10. 10 into 11 is 110 plus 25a squared plus 4a plus 44 minus 20a. So let's focus now. I have my a squared terms. So I have 26a squared minus 10a squared, so that's 16a squared. I have then my a terms. So 22 minus 110, I'm going to put that on a calculator so that I don't make a silly mistake. 4 minus 20. I'm getting 104a plus 121 plus 44 and minus 21 from the other side, so that I'm getting 144. Okay, then I can put this on my calculator with the quadratic formula: plus minus b square minus 4ac over 2a. 9 over 2 and 2. So a can be 9 over 2 and a can be 2. Does it say anything which one has to be picked as the final answer? It says a and b are positive constants. Okay, let's try to find out b first and see if we get both positive constants there as well. 11 minus 5 times 9 over 2. Okay, so this comes out as negative. So that's b, sorry, b is minus 11.5, so not possible because they have to be positive. So b is basically 11 minus 5 times 2, which is 1. So a equals to 2 and b equals to 1. Those are the final answers. Let's go on to question number 9. It says the one-to-one function f is defined by f of x equals to this, where a is a constant. State the greatest possible value of a. Now, for this to be a one-to-one function, you must cut it at its turning point. The turning point is 3 comma minus 1, which means x should be 3, and the graph is going backwards from 3. So that is what you should be aware of. Okay, question number 9 says, okay, so say the greatest possible value of a. So a is basically the turning point. It is given that a takes this greatest possible value. So now the domain of the function is x is less than 3. Okay, state the range of f and find an expression for f inverse. So I think that's simple. Now you know that your graph will have a turning point at 3 comma minus 1, whereas this graph is only going to be on the left hand side. Why? Because it can't be on the right hand side. And you've restricted the domain to just on the left hand side. So the range of the function will be y is greater than um, minus 1. Why greater than? Because you see this domain does not include 3, which just means it doesn't include the turning point. How do I find the inverse? I start with the completed square form, equate it to y, make x the subject. When I take a root, I have to be careful. What I sign, I put outside the root. So I'm going to put a negative sign because the graph is to the left of the turning point in this case. Um, so I get y plus 1 equals to x minus 3. So 3 minus root of x plus 1 equals to f inverse of x. Okay. Okay, then part B says the function g is defined by g of x equals to x minus 3 whole square for x is greater than or equals to 0. Show that g of 2x. So what I'm going to do is I'm going to first g of 2x can be expressed as this. So I'm going to first create g of x and then go to g of 2x. G of x is basically now this is a little complicated. So I have x minus 3 squared minus 3 and then a whole squared outside. So when I expand this, I can then go on and say that this is gg of 2x, and when I replace x with 2x, but I have to open up this bracket. So this is going to be a squared 2ab plus b squared. I'm going to get 2x minus 3 power 4. Okay, I forgot 2ab. Okay, that's 6, 2x minus 3 whole square plus 9. Is that in the required form? Yes, it's in the required form. And this is a power 4 and then power 2 and then a constant that this should remind you of a disguised quadratic equation. It says hence expand gg of 2x completely, simplifying your answer. Okay, it's not asking me to solve, it's just asking me to expand. Now this power 4 is basically a binomial expansion if you remember it from there. If you don't, you can just break it up into two squares and then multiply. I'm going to do the binomial expansion because that is what the question expects me to do. So I'm going to say 4c0 2x power 4 minus 0 minus 3 power 0, 4c1 2x power 4 minus 1 minus 3 power 1, 4c4 4c2 2x power 2 minus 3 power 2, 4c3 2x power 1 minus 3 power 1 3, sorry, 4c4 2x power 4 minus 4 and minus 3 power 4. Then there's minus 6 into, if I open this up, it's going to be 4x squared minus 12x plus 9, a squared plus 2ab plus b squared, and there's a 9 outside. Simplifying these terms quickly gives me, I think, 16 into 16 in the first one, so 16x power 4. 4c1 is 4, then 2 cube is 8, and into minus 3. That gives me minus 96x cubed plus 4c2 is 6 into 4 into 9. Gives me 216 x squared. 4c3 is 4 into 2 into 27 with a negative. It gives me minus 216. Minus 216x. There's an x here as well. So that gives me 81. And then I have 24x squared plus 72x plus 54 plus 9. So quickly filtering out the terms x power 4, there's no x cube, otherwise 9x cube. There are two x squares, so 216 minus 24 gives me 192 x squared. There are other x terms as well, so minus 216 plus 72, that gives me minus 144. And I have 81 plus 54 plus 9 is 144. This is x. Is that the right answer? I didn't get 36. Oh, that is minus 54. So 81 minus 54 plus 9. Yeah, that's 36. Yeah, I've gotten all the right terms. Question 10, that's the last question for this marathon. It says the function f is defined by this. Find an expression for f inverse of x. So y equals to 2 over 3 minus 2x. 2 over y. Then trying to make x the subject. Okay, those two cancels out with that. The function g is defined by 4x plus a, where a is a constant. Find the value of a for which gf of 1 equals to minus 3. I think that's easy to handle. I can just go on and say that I can first find gf of x. I will write that as 2 over 3 minus 2x plus a. This is equals to 3 when I plug in x as 1. So that gives me 8. 3 minus 2 is 1. 3 plus a. Okay, that's f of minus 1. Yeah. So that gives me 8 over 5 plus a equals to 3. 3 minus 8 over 5 gives me 7 over 5. Yeah, that is the correct answer. Find the possible values of a given that the equation this has two equal roots. So this is a question on quadratics. I have the inverse of, I have f inverse of x. That was 3 over 2 minus 1 over x. I still have to find g inverse in terms of a. So I'm going to say y minus a divided by 4 equals to x. So g inverse of x is equals to x minus a over 4. I'm going to say that both of these are equal, and then I will go with equal roots, which means that b square minus 4ac will be equals to 0. Okay, I will have to take an LCM on this side, so this becomes 3x minus 2 equals to x minus a over 4. I see a bit of reduction, so I can do that. 2 times 1, 2 times 2, and then cross multiply, so that gives me 6x minus 4 equals x squared minus ax. So I have x squared minus ax minus 6x plus 4. So my a is 1, my b is minus a minus 6, and c is 4. So b square minus 4ac, because of equal roots, is equals to 0. So minus a minus 6 whole square minus 4 times 1 times 4 equals to 0. This bracket will expand with a plus b whole square. If you are confused, just break it up into two brackets and multiply minus a minus 6 and into minus a minus 6. Okay, a square plus 12a plus 36 minus 16 equals to 0. A square plus 12a plus 20 equals to 0. Uh, I see some issue with the signs. Let's check. -2 and -10. Yeah, those are the two correct answers. Okay, that is it for this marathon. I will be back with more functions questions in a later video. Please make sure to like and subscribe and comment if you have questions. Thank you.